the next speaker is Mr. P.Arjunraj. He is a technical innovation and wave consultant, South Zone Council member, Indian Value Engineering Society, India. Education committee member in Miles Value Foundation, USA, and Save International from USA. Now, let us have a brief introduction about the speaker. P. Arjun Raj has completed the Mechanical Engineering and Specialization Master of Engineering in Automobile from Anna University, Chennai. He holds an MBA degree from Madras University specialized in operations management. He is certified value specialist, which is the highest level of certification in the field of value engineering, certified by Society of American Value Engineering. He is currently pursuing PhD in B.S. Abdul Rahman University in School of Mechanical Science, Department of Automobile Engineering. Looking to his publication, he had published eight research papers in international journals and presented 13 research papers in international conference and 8 research papers in national conference. P. Arjun Raj is the resource person from many different workshops, training programs, seminar and guest lecture in different companies, R&D institutes, academic institutes related to the value engineering, operation research, total quality management, manufacturing technologies, emission control strategies, electric vehicle technologies, automotive engines, automotive transmission, and various automotive components, product and management subjects. P. Arjun Raj have worked in BEML, Bharat, that is Bharat Earth Movers Limited, in service and validation department. Worked in Mahindra and Mahindra Limited in engines R&D and worked in PSA Group Motors in powertrain research and development department. He has been awarded and recognized by many recipients. He is the recipient of Gold Medal Award 2015-19 by Indian Value Engineering Society for the outstanding contribution related to the value analysis and value engineering in industry. He is also awarded Miles Value Foundation Paper of the Year 2016 by Society of American Value. He is certified value specialist, highest level of certification in the field of value engineering, certified by Save International USA, and approved and licensed instructor for value methodology from Save International USA. He is appointed as education committee member in Miles Value Foundation USA during June 2020. With this brief and kind introduction of P. Arjun Raj sir, I welcome you on behalf of Automobile Engineering Department, ADIT, on the STTP of Automotive Engines, Emissions and Green Fuel Technology, sponsored by Guj Coast and promoted by A.D. Patel Institute of Technology. I heartily welcome you, sir, on this session. We have almost 30 participants joined in this session. So without wasting much of the time, I am handing over this session to you. So please, sir, share your idea, your views, and enlighten us with the different viewpoints on your area of interest topic. Thank you very much, sir.
Thanks, Professor Kuldeep Patel, for giving me an opportunity to interact with all the faculty members across the country. So today, my topic is different test and standard for electric vehicle. So that is my seminar today. So I will be talking on the topic called electric vehicle test and standards. Hope my screen is visible. My my audio is also audible.
Yes, sir.
Yeah. Uh, so the title here is the electric vehicle tests and standards. So I can be contacted at P.Arjunraj at the rate gmail.com, and my mobile number is 8778983428. If in case any doubt or clarification, if you want to ask or if you want to interact with me after the seminar, you can also interact with me. So this is my presentation content. Today I will be talking on the basic concepts and terminologies which are being used in electric vehicle. Then I will talk about the importance of electric vehicle performance. Then overview of electric vehicle in India. So different type of electric vehicle, what is being developed in India, like two-wheeler, three-wheeler, four-wheeler. With respect to that, I will be giving an overview. So all these three topic I will give ahead before going to the main topic called different tests for electric vehicle and the evaluation and standards for electric vehicle. So today the topic is test and standards for electric vehicle. So I will just give an overview before going to the test what we have for the electric vehicle and what the standards we have for the electric vehicle. So the first topic is the basic concepts and terminologies in electric vehicle. So with respect to the electric mobility, okay. So we follow different mobility in India and across globe. Starting with the two-wheeler, we have electric concept or electric vehicle technology into the two-wheeler, and we have the electric vehicle technology in three-wheeler like e-autos and e-rickshaws, and in four-wheeler we have the passenger car, buses, trucks, tractors, commercial vehicles. All these vehicles are now into the electric vehicle concept. So this electric vehicle mobility is being applied across all segments of the vehicle. It's not restricted to one particular segment like two-wheeler or three-wheeler. So it's applied across all segments of the vehicle. With respect to the electric vehicle, it's not only the electric vehicle concept, but also the concept which is being adopted in the regular conventional vehicle, like what we have autonomous driving, connected vehicle, IoT, all these shared mobility, cyber security, all these are there even in the conventional vehicle also. In addition to the electric vehicle concept, so we are also having in the trends which is happening in the automotive field with respect to the autonomous driving, connected vehicle, cyber security, IoT, shared mobility. And in addition to that, we have vehicle to grid technology in the case of electric vehicle field because you need to have the charging station where you will get the charging from the grid station. So you need to have the vehicle to grid technologies for taking the power from the grid to the electric vehicle. So similarly, in the case of a normal conventional thing, we have at the station, at the petrol station we have where the petrol or diesel is being put into use to the vehicle. So this similar to that, you have the grid to vehicle technology and also vehicle to grid where if in case if you have extra charging in the case of the battery for the vehicle, so you can also recycle to it to the grid station. So you have the advantage of taking the charge from the vehicle to load to the grid, and again whenever it is required, you can take it from the grid to the vehicle. So these are the future trends which are happening in the automotive industry with respect to the electric vehicle concept. When I say electric vehicle, it's not only restricted to the electric motor or electric battery, the technologies what we use in the electric vehicle. So even in addition to that, what we have in the conventional thing is also applicable to the electric vehicle. So when I say the test and standard, so we need to do the tests individually for all these things. Okay, so there is no rocket science that what we have that the test and standards is is not applicable to the conventional or not applicable to electric vehicle. It's like similar what we have for the conventional thing, except there will be some slight changes with respect to the motors, batteries, and the battery management system, motor controller, etc., and the charging system, etc. So we'll start with the concept called electrification. So you might be knowing we have three type of electrification. One is conventional vehicle, and one is hybrid vehicle, and one is battery electric vehicle. In the case of the conventional one, you have the fuel as the input, and you have the engine. And in the case of the electric vehicle, you have battery as the input source, and the engine is replaced with the help of a motor or a generator. So in the case of regenerative braking, you go with the motor will act as a generator, and you have this transmission as usual. But the transmission what you have in the case of a conventional vehicle much more complex than what you have for a battery electric vehicle, because you can run the vehicle with the help of a single speed gearbox. Except if you're going for a truck or a heavy duty vehicle where the load is higher, then you need to have a multi speed gearbox. But with respect to the two wheeler or a three wheeler or a four wheeler passenger car, you can have the single speed gearbox where the transmission is less complicated than what you have for a conventional thing. And you also have the other type of electrification called hybrid electrification, which means you can run your vehicle either with the help of battery or with the help of the fuel. So if you, in the case when the vehicle is running in traffic condition or in the city driving condition, you can run the vehicle in the case of with the help of the electric motor. So when the vehicle is running in the national highway or expressway or where the traffic is not there, where the speed is also too high, where you need to have high performance, then you can run your vehicle with the help of engine mode. And you have the transmission similar to what you have here, and you can also have the much more effective performance when the vehicle is running in high speed or in expressway. You can run the vehicle with the help of engine, and when the vehicle is running in a city condition, you can run with the help of a motor. And you have different type of hybridization. So totally you have four type of hybridization. One is micro hybrid, mild hybrid, and third one is a full hybrid, and the last one is a plug-in hybrid. So when the hybridization is taking an evaluation from micro to plug-in hybrid, the efficiency is also going to improve from micro hybrid to plug-in hybrid. So in the case of micro hybrid, you will have only the start-stop technology, which is mostly used in the traffic condition or in the city conditions. And the next important thing is the mild hybrid. Along with the start-stop technology, you also have the regenerative braking, which will operate above 60 volt voltage condition. And you also have the electric motor to assist in combustion engine, and basically the starter motor kind of thing. And in the case of a full hybrid, you apart from the regenerative braking and the electric motor for an engine, you also have the pure electric motor. What I told. So you have the pure electric motor, not the starter motor what we use for engines. Pure electric motor which you can drive all the time using only the electric motor. And also this full hybrid consists of the technology which involves both battery and also the fuel. And the last important hybridization is a plug-in hybrid. So apart from the regular use of electric motor, you also have a rechargeable batteries, which can be extended uh, for increasing the electric range. Say, for example, in a single charge, so when you're going for a plug-in hybrid electric vehicle, you can have in a single charge, you can run your vehicle to up to 20 miles per hour, up to 20 miles range, or 40 miles per range. So here you have different types like PHEV. PHEV stands for plug-in hybrid electric vehicle. You have PHEV 20, you have PHEV 40, you have, which means the 20 and 40 here indicates in a single charge, the vehicle can go up to 20 miles range and 40 miles per range. So that is possible with the help of a rechargeable batteries, which is coming from the uh, uh, outlet arrangement which will be used for extending the electric range. So this is the new concept which is being used by many players like Toyota, which they use it in the Prius vehicle. And initially the Prius vehicle was with full hybrid, then they evolved in even in plug-in hybrid also. Even the Chevy world, okay, even they also into the plug-in hybrid concept. So when you're going for a hybridization from micro hybrid to the plug-in hybrid, so what happens is your efficiency is going to get increased. So the first is the example of a micro hybrid is the Citrian. This is a PSA motor. I was working in a PSA company. It's a PSA motor. Before I being a consultant, I was there, and in France they do the micro hybrid model, and even they also have the electric vehicle concept, and even they have the full hybrid also in France and Europe countries. And in mild hybrid, when I was in Mahindra, I was developing the mild hybrid using the regenerative braking and also the electric motor concept for a starter motor kind of thing for an engine Scorpio I have developed. And a full hybrid its example is Toyota Prius. Um, recently I'm involving for a consultant in some of the companies which involves a two-wheeler and three-wheeler, uh, but I have not worked for a hybrid concept, but the integration concept I know very much better. And the last important thing is the plug-in hybrid. Okay, so again, it needs a lot of time to get an exposure with respect to the plug-in hybrid. With respect to the exposure, in the sense, it's not respect to the theoretical exposure, but what I'm telling is the practical exposure. So recently, I myself had engaged in helping the consultant as a consultant to many OEMs, basically startup companies. Many are in Bangalore, a few are in Pune, and some of the company are in the Chennai. So I'm helping many OEM startup um, for developing some of the technologies with respect to the electric vehicle. So all these are very not a new concept, but just giving you an overview. With respect to the energy loss, what we have with respect to the engine. In engine is having almost 76% of engine loss. Okay, because you have a lot of losses. You have heat loss, time loss, blow by loss, blow down loss, pumping loss. Because of all these losses, what happens is you get almost 76% waste, which is coming out of the engine. You get as a loss. Okay, so that's why you get the 76% engine loss out of 100% of efficiency what we are going to get from the fuel. And in the case of city driving condition, almost the vehicle is going to stand. Okay, so which 8% losses, and only 16% coming to the drive line. Again, you get 3% loss in the case of the drive line losses, and you get only 13% which is going to the wheel. And apart from that, it is also related to the aerodynamic aerodynamic drag, rolling drag, and also the braking force. All this will also contribute to the losses. So finally, you are going to get only 30% when you're running the vehicle with the help of the fuel and engine. And when you're going for a hybrid and when you're going for uh, a pure electric vehicle, what happens is this percentage is going to get increased. We will see how it is going to get increased. So again, when the vehicle is running in a highway with respect to having the fuel and engine, so you don't have the standby loss, which means you don't have the waiting percentage. So you don't lose. Because in the case of city condition, most of the time your vehicle will be in start and stop condition. So most of the time it will be in standby, and you get losses of 8%, which is not going to happen here. But the engine loss is slightly going to be higher than the city condition. It's not 1%, but still theoretical one, but still it will be higher. When I was in Mahindra, I do a lot of research to reduce the engine loss. Uh, but we do a lot of research how to reduce the percentage loss, heat, the time, and blow by loss, pumping loss, friction loss. So all this is very challenging one again. And again, the more you reduce, it will also increase the cost. Okay, so there are a lot of challenges. I also had a sleepless night, 3 4 days continuously for doing some of the combustion development when I was in Mahindra. All these issues are there when you're going for this type of things. And you get only 23% which is coming to the drive line, and again you get drive line loss of 4% almost. We're going to get only 19%. And again you have the aerodynamic rolling and braking. In the case of when the vehicle is running in highway, you apply the brake very less when compared to start-stop condition. That's why, and again the aerodynamic force is going to be higher because the air which is going to come is going to be higher. Okay, the force which the air strikes the vehicle is going to be higher, and again the rolling resistance is also going to be higher because the speed of the vehicle is higher. The next important thing is the hybrid system. So hybrid involves four technologies. One is micro hybrid, where you have the start-stop technology where you can eliminate the standby of 8%. And the next one is mild hybrid, where this mild hybrid is also having the regenerative braking technologies. And the third important thing is the full hybrid, where you can also run your vehicle either with the help of engine mode or with respect to the electric mode. So in such a way, you can downsize your engine, and also you can decouple the engine along with the flywheel. And the last important thing is the plug-in hybrid electric vehicle, where you can also eliminate the engine coming entirely. And the same thing when I'm comparing the energy loss with respect to the engine and also with respect to the electric vehicle. So here the engine is replaced with the help of motor, and fuel is replaced with batteries. And unlike the 76% loss what we have in engine, the motor loss is only 10%. Still, there are a lot of research is going on even to reduce the motor loss also. So as I said, I am being a consultant. I have seen some of the companies where they even trying to make it as 8%, 9%, even between 9 to 10% also, because they are trying to reduce the loss of the motor as much as possible. And the driveline loss, what you're going to get is going to be higher than what you're going to be in engine. So it's going to be 14%. And this is also very challenging. To reduce the driveline loss also is very challenging because you have only single speed gearbox, and but unlike in the case of a commercial vehicle where you have multi-speed gearbox, because you need to have the multi-speed gearbox in the case of commercial vehicle like the buses or into the trucks category, because you need to have a lot of load for which you need to have more torque. So in that case, the driveline losses will also be higher. Considering that, between the motor loss and the driveline loss, the overall the efficiency is going to be 76 percentage, unlike you get the 13 percentage in the case of the normal engine. So here the efficiency is going to be much more higher. But with respect to the aerodynamic structure, so the force is going to be higher and rolling is going to be slightly higher, and the braking is also, since you have the if you have the regenerative braking kind of thing, still you can reduce the percentage. But even the performance of the electric vehicle is correlating with respect to the mileage what you have in the case of the engine. So here in this case, you have the ranges equal to that of mileage in the case of electric vehicle. Okay. Next one is the wheel to wheel efficiency. Just give me a minute. Yeah. Next is the wheel to wheel efficiency. So when I say there is a lot of losses going to happen between the comparison, and I compare between the engine and the electric vehicle. So here this comparison is quite interesting. So this is the regeneration, the generation of 33 percentage of the electricity, which is coming from the power plant or power station. When you generate, you're going to get 33 percentage, and same input which is coming from the oil refinery, you get 82 percentage. You see that the efficiency is going to be higher for a gasoline or a diesel, where you get 82 percentage, whereas the electricity is what you're going to get is only 33 percentage. There are a lot of losses you're going to get here. Okay, when it is taking from the power plant, it can be the thermal power plant or a nuclear power plant, whatever it is. Okay, and again you see when you're transmitting it to the grid, this is the grid where you charge your vehicle, and similarly where you take the fuel from the petrol station. Um, when you're transmitting, you're going to get 98% efficiency. Still, you see, still this is higher. Still this is higher. Okay, again, when you're transmitting, also you're going to get some losses, and only you're going to get only 31 percentage when it comes to the grid, and when it comes to the petrol station, it's going to be 80% efficiency. So up to this, the engine is much more higher than the electric system. And you see the beauty here, when it is this 31 percentage, when it is going to the vehicle from the about the plug concept. Okay, this plug actually. So you plug the charging thing from the grid to the wheel. So here the efficiency is going to be 76 percentage. Okay, so it means 31 percentage you get 23 percentage efficiency. But you see here, when it is going from the pump to the wheel, okay, it is only going to be only 16 percentage. Okay, and finally you're going to get only 13 percentage when it is going to to the the vehicle. You see the beauty here, when it is coming from the well in the sense the input. Okay, the source, the starting source for the electricity, or starting source for a diesel or a petrol. So you see only 13% you're going to get in the case of the engine, and 23% you're going to get in the case of electric vehicle. And apart from that, you have the advantage of reducing losses, engine loss you can reduce. Then almost 66% you can save here, and again 10% you lose here. Almost 56% still you're going to be higher. And these are the advantages that you have. Okay, so I told you you have the plug-in hybrid electric vehicle where you have 20 PHEV, 20 PHEV 40, and nowadays even PHEV 60 also to some extent it's there. And you'll see here what is the principle behind the PHEV is that I told you you have two. PHEV is also a hybrid kind of thing where you have electric concept and also the engine concept. But you have an option to eliminate the engine if you require. But most of the things you have the engine along with battery. So when the vehicle is running in the city condition or in the starting condition, basically you start your vehicle with the help of a battery mode where you have different type of percentage of battery charge, and then you transit from the hybrid to the engine mode where you run the vehicle when the vehicle is running in high speed and national highway or expressway, and where you need to have high performance. You need to run your vehicle with the help of the engine mode basically. So initially the engine mode will be in off condition, then it will be in on condition when the distance is going to be higher. So when the distance is going to be higher, it will be with the engine mode, and when the distance is going to be the starter, which means from the start, it will be running with the help of the engine electric vehicle mode. Okay, so these are all the terminologies that normally you need to use for electric vehicle. So from this slides onwards, I request your support to have in-depth attention because whatever I told you previously, you might be knowing, but this is very important because before going to the test and standard, you need to understand all these terminologies. Okay, because with these terminologies only, we are also going to test the individual thing. It's when you say testing, it's not with respect to only uh, the complete the vehicle alone, but we need to test individually also. We need to test the motor, we need to test the battery, we need to test the individual subcomponents which are there in the vehicle. So what we have the test for the conventional vehicle, we also need to test the electric vehicle as well. So and again, engine is the heart of an electric vehicle. Sorry, engine is the heart of a normal conventional vehicle, but the battery again is said to be the heart of the electric vehicle. And again, when I say it's a heart, it is having different terminologies that you need to understand. So the first important terminology is state of charge. So state of charge is nothing but when the battery capacity is expressed in the maximum capacity in percentage, you call that as a state of charge. And the depth of discharge is nothing but the percentage of battery capacity that has been discharged. And you have the capacity, which means it is expressed in ampere hour when the battery is discharged at a specific current, and it's also been rated as C rate from 100% of state of charge. And you have energy, which means the total watts hour. The unit here is watts hour, and this energy is the one when the battery is discharged at specific current, and it's also specified as a C rate from 100% state of charge. We have specific energy, which is expressed in watts hour per unit mass, and you have the specific power. It is expressed in the unit called watts, and it's the specific power is again a function of internal resistance of the battery. And the specific energy is expressed in watts hour, which is nothing but energy to that of mass. Mass is expressed in kg. So these are some of the terminologies that you need to look into it. When I say it's a battery specification, you have terminologies which indicates the state of charge. The state of charge includes the stored energy plus inactive part. Basically, the battery is having the empty portion at the top and inactive portion at the bottom. You have the stored energy in the middle, and the overall the battery from the empty space to that of the inactive region, you call that as a rated capacity. And the available capacity is basically between the empty to the top the stored region. This available capacity it represents the actual play field. and the capacity and the state of charge determine the runtime, but you have the siblings also. Sibling in the sense, what are the siblings here is, apart from state of charge and the data capacity. So here there are different siblings. It is correlating to that of the play field, like an inactive region. So you need to see the runtime of your battery, and according to the runtime, you also need to ensure that how much is the state of charge, how much is the depth of charge, capacity, energy. So all these are been specified considering the battery specification. So you have different type of batteries. So lead acid battery has been used in last decades, but nowadays we are going with lithium ion, and we have a lot of advancement even in lithium ion. We have lithium ion polymer, we have lithium ion phosphate, and even a lot of research is going on with lithium sulfur. Okay, and even nowadays you also have different batteries like graphene technologies. You have, irrespective of that, again, battery selection is based on high power to high energy to weight ratio, and also the battery should have high energy density. Higher the energy density, when the weight can also be lesser. When you are going for any test on the standards, you have the individual standards for the battery. For the individual battery, you have the individual test and individual standards. The test remains same because the test procedure remains same for the different type of batteries, uh, but the standards might be different because the chemistry is sometimes going to get varied. But irrespective of that, it should uh, it should have the sufficient the required energy density, and again it should also have the particular weight, because it's higher the weight is always a problem. So that's why the lead acid weight battery is almost three times higher in weight when compared to that of lithium ion battery. Even this will also higher the weight, it will also contribute uh, to the additional problem with respect to the complete vehicle also. So you need to, when you are going for a design selection of any battery, you need to see that you are going to have the selection having high energy density and also the less weight. With respect to the changes, what we can see from the IC engine to the top for the electric vehicle is, engine is replaced with the electric motor. So engine is the heart here, and the motor and the battery is going to be the heart what we will have for the electric vehicle. And you have engine management system, but you have here a battery controller, sorry, motor controller you have, and the fuel is going to be the input, and battery is going to be the input for your electric vehicle. And you have the petrol station, and you have the electric charging station in the case of AC engine, in the case of electric vehicle. So why we need to go for electric vehicle? It's because the electric vehicle, the torque is going to be high even when the vehicle speed is going to be lesser. So the electric motor can produce a torque even at the starting RPM or 0 RPM. And again, it maintains a torque constant, and this torque is going to be higher than what the torque you're going to get out of the IC engine motor. So considering this, you have better efficiency for electric vehicle with respect to the torque point of view. And considering this reason, you're going for electric vehicle. And even the electric vehicle do not require multi-speed transmission. I told you initially, with the help of electric vehicle, you can go with a single-speed gearbox, where you no need to have the multi-speed transmission also. But some other vehicle like Ashok Leyland, they go with the multi-speed transmission also, because the load is going to be higher for some of their applications, for bus application, because bus is going to be completely with lot of loads, because the passenger is going to sit, more passenger are going to sit, maybe the vehicle with the 60 seat or 80 seats. Okay, and on an average, if the weight of the person is 60 kg, so 80 into 60, you can see almost 4,800 kg. Okay, so that much weight is required. So for which you need to go for a multi-speed gear transmission. Um, But for passenger car or for a two-wheeler, you want to go for a multi-speed transmission. So we have different type of motors. We have DC motors, AC motors, and again DC motor converter is divided into brushless and brushed DC motor. And you have series wound, shunt wound, compound wound, permanent magnet brushed DC motor. So in most of the things, even for a Tata Nexon, even for that we are going for a permanent magnet thing. And even but the cost is going to be higher when you're going for a permanent magnet. The cost is going to be higher. Uh, and you have the AC motor, which it is divided into synchronous and asynchronous induction motor. And induction motor is again divided into single phase and also three phase. Um, and again, you need to select the motor considering the speed and the torque range and the power what is being required. And I'm not going to debate which motor is best, but of course, if you want to have more speed, then PMS permanent magnet will be but again, the cost is also going to be higher. Okay, so you need to select the motor considering the cost versus the performance. Okay, and again, this is the characteristic curve of electric motor having the speed in the x-axis and torque in y-axis. You can see the torque is going to be higher when compared to the IC engine, but again, even the torque will range between the maximum to minimum, and you can see the continuous rating torque is going to be almost 30 to 40, 35 to 40 newton meter, and the maximum is going to be much more higher. And again, you see when this is the torque curve, the torque is going to be higher initially, and it will reduce beyond the rated speed or the speed which is been specified as per the specification or as per the target. But unlike in the case of the engine, where the torque is going to be lesser, and even the torque is going to reduce, the torque will increase from low RPM to the mid-level RPM, then again it gets reduced in the case of an engine. But when compared to that, the motor is much more better. But again, you need to select the motor. As I said, you have different type of motor. You need to select a motor depending upon the torque which is being required and what is the speed at which your vehicle needs to be operated and what is the power required. So considering that, you can select the requirement of the motor, and for which you do different type of tests and you have the standards also. This is the manufacturing process of electric vehicle batteries. It's not only for a car, but this is the manufacturing process of the electric vehicle battery basically. So the source here I got from the BCG analysis. So it's basically having 7 stages or 7 steps to manufacture a battery. So first the raw material is coming there, and you do the component production, where you manufacture anode and cathode. Anode is indicated as two straight lines, and cathode is like a rectangle. So first, in the first stage, what you do, or in the first step, what you do is you do the component production where you manufacture anode and cathode, and again you also have the active materials, binder, electrolyte, and separator. And you have the next stage where you do the production of cells, and it's basically an assembly of a single cell. Okay, so the battery will have different cells, not like it's a combination of individual cells. First you do single cells, then what you do is then you go for a module, the third stage, where you configure the cells into the larger module, which involves many single cells, and again you put the electronic management also into the system. And then what you do is you pack it. Okay, you pack. So this is the one cell, this is second cell, this is third cell. Okay, and this is the management system, the electronic management system. So all this you pack the complete thing, and we are going to put it together. Packed in the sense we are going to integrate it, and we are going to install, and we are going to put it for use. And then you are going to integrate this to the pack assembly to the vehicle integration. This is the vehicle. So mostly the battery will be in the front side. Okay. So it is like a front engine and the rear wheel engine what we have. And again, even some of the vehicle will have even the rear wheel also. So it depends upon the vehicle requirement and configuration what the vehicle particular vehicle is having. And this vehicle integration needs to be done after the packing assembly. Then after the vehicle integration is been put into use, and then after use, what you do is after the life of the battery, it can be even reused and even recycled, and again, it can be taken again for the recycling process as well. So here, when I say you are going to, you need to reuse or recycle, so that will happen at the end of the life of a battery. So nowadays, most of the OEMs are giving the battery life for almost 7 years. So in the case of the Renault Tweed, um, they given almost 7 years warranty. And again, most of the OEMs, what they're giving is they're almost nowadays giving 7 to 8 years warranty for a battery. And again, this battery is also having the cycle time, so it needs to run for 2000 cycle. So when I say a cycle, one cycle will be close to 250 kilometer. So you also have the warranty, so beyond 2000 cycle or before 2000 cycle. If the battery is going to fail, then there is a warranty for the vehicle for the battery. But beyond the warranty, now even you also have extended warranty for which the particular OEMs are going to give up to eight years warranty as well. So these are all the feature batteries that you have. You have the silicon-based battery, sodium sulfate battery, um, and currently I was also working for lithium sulfate battery for one of the OEMs in OEM is a startup company in Pune, along with the IIT Bombay and one of the technologies that they have developed. I was also part of that recent activities I'm undergoing. And you also have the proton batteries, you have graphite batteries, you have aluminum ion batteries, you have nickel zinc batteries, you have potassium ion batteries, you have salt water batteries, and copper polymer batteries. So these are all the 10 disruptive technologies with respect to the batteries. So what the lithium sulfur battery is going to have is it is much more better than lithium ion battery. Even the energy density is also going to be higher, and even the range is also going to be higher. And but it is not put in use, but it is in trial stage where they are doing some of the vehicle level test. The test is that from Delhi to Mumbai in a single charge, you can run your vehicle from Mumbai to Delhi and Delhi to Mumbai, which means almost 1,000 kilometers it can cover in a single charge using lithium sulfur battery. But again, it all depends on the vehicle configuration and other aspect also, and even the chemistry what we have in the case of battery. So it is again is much more complicated, but it's not a complicated one. But again, you need to test such a way to ensure that the requirement are being met. So what is the perception about the electric vehicle mostly? So the perception is the fuel efficiency is good because you can save the fuel. Almost 95% people they are giving a positive feedback, and even they are telling the maintenance cost is going to be lesser. And there is a problem. Even the pricing also people agree, but they do not agree with the riding range, model and appearance, charging infrastructure, and the dimension and shape. So I will tell about the riding range. Okay, so when you're going for a two-wheeler purchase, so even most of the city driving people, what they want is they want to ride the two-wheeler rather than four-wheeler because of the traffic. So when I say riding range, um, people say less percentage, and they're not happy with the riding range because they need to charge the four-wheeler or two-wheeler. But again, when you take the two-wheeler, so the usage can be 30 to 35 kilometers per day. And again, you can recharge, or you can charge your batteries during your weekend or weekends, basically Saturday or Sunday, depending upon the holiday what you have. Uh, but when you're going for a four-wheeler application, there might be possibility that you will be driving in a long distance, okay, maybe 100 kilometers, 200 kilometers. So in that case, there might be a problem of the riding range. But again, for a two-wheeler perspective, it is not an issue. But for a four-wheeler perspective, even if the kilometer is going to be lesser, it's okay. But if the kilometer is going to be higher, then there might be issue. Um, but this riding range can be overcome with respect to the analysis particular community or a particular persons have to analyze before buying the vehicle. And the model and appearance. Initially, the model and appearance is not good, but now they have done a lot of model appearance aesthetics. They have improved, and with respect to charging infrastructure, okay. So nowadays even you have the fast charging where we can reduce the number of charging hours, and you have the battery swapping technology where you can swap the battery, and you can put, and you can circuit charging can be done maybe in 10 minutes time also. Even this can be overcome nowadays. And initially there was a issue with respect to dimensions and size. But for the vehicle called Ether, when I was doing some of the consultancy work for them, it's a two-wheeler company. So they initially they faced some of the dimensions and size issue, because when you're going for a two-wheeler application, or even when you're going for a four-wheeler application, normally the center of gravity of the electric vehicle will be lesser than what you have for a conventional vehicle. So considering that some of the dimensions is going to be varied, and you need to have the greater stability. So I've seen the other vehicle, they have done a very good um, the dimensions and size as well. So all this negative aspect is also being overcome with the help of recent advancement that we have with respect to the charging, with respect to the even the riding range. And I cannot tell 100% on the riding range, because it needs still a lot of improvement. But again, for a two-wheeler perspective, it is good. And again, it is most viable one for a two-wheeler with respect to riding range, because you are going to use very less kilometer per day, maybe from office to home, or office home to office. In that case, you can have um, the better perspective with respect to the two-wheeler aspects rather than going for a four-wheeler. So this is the electric vehicle working. This is the line diagram, or the diagram what I'm showing is for a two-wheeler application. And I will also show you the electric vehicle working for a bus application when it comes to the overview of the, the bus, what we can see. So you have the battery, you have the bidirectional converter, DC to AC, DC to DC, and again you have the high voltage bus, you have the bidirectional power electronic motor drive, you have the motor and generator. So you have the transmission which is going to the wheels. So in the case of regenerative braking, what happens is from the wheel, uh, from the wheel you are going to get the energy, and it will get stored in the battery. Okay, and how it is going to have is when you apply the brake, um, that the brake is coming to the wheel, and the motor will act as a generator. And again, in the case of regenerative braking, the motor will act as a generator. And again, it drives the motor, and it goes to the DC converter. And again, what happens is here you are going to get low voltage, and again, whatever the current what you are going to get, it will be stored like as a battery, and that current can be used further whenever it is required when the vehicle is running in non-regenerative braking mode. So next topic is the importance of electric vehicle performance. Why we need to have the electric vehicle performance? So you have the concept called FAME, which stands for Faster Adaptation and Manufacturing of Electric Vehicle. So under this concept, FAME 1 was there up to April 2019, but from April 2019, 1st April 2019 onwards, they have implemented for FAME 2, FAME phase 2 basically. FAME 1 is nothing but FAME phase 1, and FAME 2 is nothing but FAME phase 2. So this FAME phase 2 will be there for another 3 years up to April 2022. And this what is this FAME is all about? This is FAME is all about the categorization into three segments. One first segment is demand incentive based battery energy content, and second segment is charging infrastructure, and third segment is information, education, and communication. So these are all the different components that particular segment is having. So and again, with respect to the years from starting from 2019 to 2022, for each and every year, the budget is being allocated by the government through the FAME concept, Association of the manufacturers, and also the FAME, which stands for Faster Adaptation Manufacturing Quality Vehicles. So they have allocated 8596 crores for the demand segment alone. And for charging infrastructure segment, they have allocated almost 1000 crores. Okay. And for the information, education, and communication kind of thing, they allocated 38 crores. Okay. Under this concept of the three segments, overall almost 10,000 crores had been invested by the government agency through the concept called FAME. So considering this, you need to the, since this much amount has been allocated by the agency, then it's very important to maintain the electric vehicle performance. And again, this electric vehicle performance needs to be applied in all the vehicle, two-wheeler, three-wheeler, four-wheeler, hybrid, and also the bus, trucks, etc. And again, there are a lot of incentives even under the FAME concept. A lot of incentives also is there. When I say it's a demand incentives, it is also based on the batteries the source here, for which the battery size will vary from 2 kilowatt hour to 250 kilowatt hour depending upon the vehicle category. According to that, the number of vehicles which will come under the different categories also mentioned. For two-wheeler, almost they are giving for 10 lakh vehicle, and where it will come around 2000 crore funding is been allocated. And different vehicle will have different allocation of the thing. And again, you have almost close to 8,596 crores only for this demand incentive alone, which is the one of first segment. Okay. And you have three segment, and for this demand incentive you have more 896 crores, what I told. Okay. And the remaining charging infrastructure, and again, I told you, you have different type of charging, fast charging, swapping. You have a lot of things, and for that almost 1000 crores have been spent. And the education, communication, and information point of view, they also spend almost close to 38 crores. Almost 10,000 crores have been spent under the concept of FAME for developing the electric vehicle in India. So that's why you need to have the higher electric vehicle performance as well. And again, this electric vehicle performance is not only based on the powertrain, what you have, the battery, or the motor, or the efficiency of the system alone, but it also based on the electric vehicle, the complete design as well. It's not only the engine, it will determine the mileage of the vehicles, because the complete design of the vehicle is also responsible for the overall mileage of the vehicle. Similarly, the battery management system or the motor system is not only responsible for range of the vehicle, but again, the overall vehicle with respect to how it is overcoming the aerodynamic force, braking force, and rolling force. All this needs to be taken into account when you are going for the performance of the vehicle. Uh, and again, when I say performance, it's related to the power, speed, torque, and also the range of the vehicle. And again, so it all depends on the specification what a particular vehicle is having. And again, the vehicle category can be different. It can be a bus, or it can be a two-wheeler, or it can be a passenger car, according to that, the, 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 the government or the norms is having the different specification. This is the one of the snapshot which I have taken from the Directorate of Urban Transport from Government of WDS. So this is the characteristics of a bus, basically the AC bus, having the length, the width, height, wheelbase, and again the number will vary with respect to the passenger car or trucks or tractor. Depending upon the category, it will vary. And again, all this needs to be as per the Motor Vehicle Regulation Act, and again all this should be principally agreed, and the standards should be followed as per the CMVR norms. And you also have the overall weight. According to that, you need to design the vehicle, and you have the norms, and you need to maintain the norms. Okay, and you need to maintain the standards with respect to the speed, the communication system, and also the motor coolant temperature, basically the battery kind of thing. All these requirements you need to maintain when you're going for the standards as well. And again, the important aspect with respect to the importance of the vehicle performance importance is, with respect to a different category of the vehicle, you also have the different range. For example, for a two-wheeler and three-wheeler, the minimum range is 80 kilometer per 80 kilometer per hour is the minimum range. And again, it is as per Indian driving cycle. And whereas in the case of the European driving cycle, it will be 120 kilometer per hour, and in the case of US cycle, it will be 140 kilometer per hour. And again, it will vary. Again, it also depends on the vehicle category also. And again, you see here the range you should have minimum for a single charge, or the range what you have with respect to the single charge, and also with respect to the speed what you have. It should be 80 kilometer minimum range that you have for two wheeler, and you should have at least for a four-wheeler segment, it should be 140 kilometer. And again, the fame also they given the energy consumption values. For 100 kilometer, it should consume less than 8 kilowatt hour in the case of two wheeler, and in the case of a four wheeler, it should consume less than it should have it should have a maximum energy consumption of 20 kilowatt hour. And even they also specify the acceleration of the vehicle. Okay, all this needs to be considered, and when you consider all these parameters, then only the vehicle are eligible for adapting for coming under the FEM concept. Otherwise, they are not eligible basically. So we will see the overview of electric vehicle in India. Then we will go with the main topic called distance standards. So in India, we have developed a lot of vehicles. We started with Mahindra Reva, Mahindra E2O, BMW i8, and we have the Mahindra Electric E Verito, and again Volvo XC90 T8 Excellence, BMW i8 Roadster. And so in India, we started with 2001, and we are in 2020 now, almost 20 years. There are a lot of vehicles we have developed in India. And even with respect to the bus application as well, even Rajasthan Leyland will come up with the buses. Even when I was in Mahindra, I have developed the normal Supro, not the e-Supro. I was a part of the engine development and for the Supro vehicle. Same year, they also started with the electric Supro. I was not a part of e-Supro, but I was a part of the Mahindra Supro for conventional vehicle. So they launched the E version in the year 2015, and there are other players like Nissan, Tata Tiago, Tigor, Hyundai Kona, Hyundai Ioniq. So all these are the players that they came up with a lot of models. And again, with respect to the bus application, Eicher, JBM, Tata Star Bus, they have developed the electric vehicle concept. Okay, so with respect to the electric car, so I'm going to compare the three SUV in India. Basically, the Tata Nexon, MG Motors, and Hyundai Kona, having different length, width, height, and So when I say the range of the vehicle, the range is similar to the mileage what you have for an IC engine. So this range is not only depending upon the battery power or the torque what the vehicle is going to have, but also depends on the complete dimensions and also the overall structure. As I told you, you need to have uh, the design of the vehicle with respect to the complete thing where you need to overcome all the effort of aerodynamic, rolling, and also the braking. So considering this, the three players they play a vital role in India with respect to the electric vehicle car concept in India, and the acceleration is also good. The range is also better for this vehicle, and again the price is ranging between 14 to 23 lakhs. Tata Nexon is the most viable one with respect to the cost also. Um, so now we'll see with respect to the electric bus application. This is the example that I'm going to give from an Ashok Leyland vehicle. So the Ashok Leyland electric bus technology is divided into three system where they have the charging infrastructure where it can be overhead induction or plug-in, where they also have the overhead line and they also have the pantograph. Induction can be either static inductive method or dynamic inductive method, and you have the plug-in hybrid plug-in charging infrastructure. And in the case of energy storage system, you have ultra capacitor, battery, fuel cell, electric fuel cell, and you see here. And in respect to battery, you have different types which the Ashok Leyland is going is with lithium ion phosphate, lithium ion, and also these two are mainly being used. And even they go for nickel, metal, cobalt also. Titanium oxide, but titanium is too costly. And when you go for a propulsion, it can be either electric or it can be a hybrid. And when you go for a electric, it can be pure electric or rechargeable energy electric vehicle. It can even be the parallel hybrid or combination of that. This is the electric vehicle bus in architecture. So it is having the AC charging, DC charging, and depending upon the flexibility, which charging needs to be used can be used for this vehicle. And it is having the auxiliary power unit or APU controller, and you have the nickel metal cobalt battery. So here you have 650-volt DC link, and you have the auxiliary inverter, uh, and again you have the auxiliary drives for the vehicle, like you have the compressor, steering, HVAC system. And I told you you need to have a multi-speed gearbox for a commercial vehicle, basically the bus kind of thing, where the load is going to be higher. So this Ashok Leyland is going to have the traction motor with multi-speed gearbox. This is the body control unit. Okay, so this is the overhead line of charging. You are going to charge your electric bus with the help of overhead line. And this is the plug-in thing where you are going to charge with the help of plug-in. And this is the pantograph. This is similar to the one what you have for uh, the train system what you have, electric train, where you use pantograph. Similar to that, you have the pantograph for charging your electric bus. And you have the induction principle where it can be either static or dynamic thing, where you use the input power and you are going to get a electromotive force, and the force it creates a magnetic field. An electromotive force has been induced, and you are going to charge your vehicle with the help of the induction principle. So some of the electric scooters what we have in India is the Ether, Revolt, Bajaj Chetak, TVS iQube, iPrice, Hero Photon, 48 volts, and Torque. So all these model are there in India, and having different price, different battery capacity, range. Almost you can see the range is on an average almost 80 kilometers is the average range. And we also have the charging time, 5 hours or 4.5 hours. This is quite less actually. 5 or 4.5 is quite less. and again you can charge it during the weekdays mostly. And again, the top speed also quite good for all these things. Two-wheeler is quite comparatively good because you're going to also going to use less time. Suppose if the distance between your home and office is only 10 kilometers or 5 kilometers, still it will be much more efficient to ride your vehicle two-wheeler rather than going with a four-wheeler electric vehicle. And this is the example of the comparison between the other 450X and 450. 450X is the advanced version of 450. And when I'm comparing that with the 150, 125cc and 110cc scooter, even the torque is going to be higher. The speed is also going to be comparatively same. And you see the range per mileage is going to be higher. Okay? And again, the power is almost going to be same. And you see the weight is slightly, there is a, see, as you know, the battery weight is to be higher. Still, the overall weight of the vehicle is almost comparatively same to that of the 125cc motor and 110cc scooter. And again, the price is going to be slightly higher, but the advantage what you have is you can save the fuel cost, you can have the less maintenance cost, and over the 5 years, almost the savings is going to be 75,000. You can save almost 75,000 in 5 years period when you go with a two-wheeler electric than when you're going for a normal conventional two-wheeler. So with that 75,000, even you can go for a 50% cost for your new vehicle also. Your top speed is also good, not too bad, and you are not going to increase the vehicle when the increase the speed when you're running the vehicle in a traffic condition. Compared to that, this is good actually. And even this 450X can also be compared with the other players like Vespa, Govex, Bugaro. Comparing to that, still it is good. And we are the Indians are to know the global leadership, and we have a very good opportunity. Okay, now I'm going for a different test for electric vehicle. So directly, I do not want to start. That's why I given an overview what is happening. Uh, so now I'll go to the topic different test for electric vehicle. Why test is required basically? Okay, the test you need to test everything because you need to ensure the durability of the vehicle. If you're not testing, you cannot be able to understand what is the durability of the vehicle that you have. The factors affecting the electric vehicle durability includes different parameters. First one is the depth of discharge of battery. You need to know how much is the percentage of the total energy left in the battery, okay, for which durability is very much important. Then the static state of charge of the battery, and this will determine what's the level of charge of the battery when the vehicle is running in the standby mode. And the charging rate is the one which determines the rate at which the charge is going to be charged. So drive cycle. So you have different drive cycle. When you're running the vehicle in city condition, the speed will be lesser, and when you're going for a highway, the speed will be higher. When you're going for a combined cycle, it will be mean of both city plus highway by divided by 2. And so all these factors will affect the electric durability. And again, the temperature. So when the temperature of the surrounding is going to be higher, and again you are going to have high temperature into the battery also, and again you need to have proper cooling to reduce the temperature also. And even the thermal management is also a quite complicated thing. Even when I'm doing consulting activities, I face a lot of problem with respect to the four-wheeler segment rather than two-wheeler and three-wheeler. So that's one of the the problem or the bottleneck that you have with respect to the thermal management system. And because in the case of two-wheeler and three-wheeler, you can cool with the help of the air method, but when you're going for a four-wheeler, you need to go have some coolant to reduce the temperature, battery cooling system basically. So again, it also depends on battery durability is also based on the driver driving condition. Sometimes they apply the brakes very fastly. They will increase the speed. So it all depends on the aggressiveness of the driver as well, and again the environment. Okay, and also depends on the temperature. So whether the vehicle is running in a hot condition or cold condition or in warm condition. It all depends on the environmental as well, and also the daily usage. So all this will have the effect on the electric vehicle durability. Uh, and when I saying the electric vehicle testing methodologies, you have different type of methodology. So you have five methods, the five concepts, five steps. So here, first one is the elevated storage temperature. So here, the vehicle will be stored at an elevated ambient temperature for a period of 2 months. And then what happens is, when the temperature is higher, what happens is it will also affect the battery capacity of your battery. Then after keeping the vehicle, it will be stored for almost 2 months at a elevated high temperature. So the battery capacity is being tested, and how much is the loss you are going to get, that also gets determined. Okay, this is the first method or the important methodologies that you need to follow. And the next important thing is with respect to battery, what is the rapid charge and what is the rapid discharge. So the vehicle will be charged and discharged at a much faster rate than the normal. For example, for 20 cycle, one cycle will be 250 kilometers, for example. So 250 into 20 will be 5,000 kilometer. So the vehicle will be run for 5,000 kilometer without any rest. Okay, without any rest. Okay, and then and and they will also calculate. They will calculate what is the minimum time period which the maximum time period which it is going to get the charge and discharge. They will take the readings and they will have it for the reference. And then they also do the thermal shock test where the vehicle will be uh, thermal shock in the sense from hot temperature to low cold temperature and cold to hot. So when you expand the temperature and when you decrease the temperature, what happens is the thermal expansion and contraction will happen. It will also affect the battery system or battery environment. And again, you have the mechanical vibration where you need to do the vibration test. It's basically NVH test you do. Uh, Here we have we'll be keeping the vehicle in a shaker table where it will shake in different direction, X direction, Y direction, Z direction. And then the next is the end of life of a vehicle and battery testing. So we do all these things test for a two-wheeler, three-wheeler, four-wheeler segments. So this test is conducted mostly on hybrid electric vehicle. Even in the case of electric vehicle also, they do considering the 1,60,000 test miles. So when you test the vehicle, uh, it's not only with respect to the battery but also the end of life, whether the vehicle is withstanding without any failure for that 1,60,000 or not. So when you're going for the testing, okay, what is important is you need to integrate all the areas and you have to test it. So it is very important to test individually. Like you need to do the brake test, noise test, vibration test, steering test, brake test, suspension test, powertrain test. You have individual test, okay, for the individual system. But but apart from that, what you need to do is that you also need to integrate all these systems. Along with that, you also test with respect to the safety, with respect to the weight and the ergonomics, and what is the energy you are going to get. And finally, you're also going to validate it. Validate in the sense you do the test, you do the city driving test, you do the highway driving test, and you do the test considering the different temperature range. And finally, you also going to do the integration considering the regulation, the standards. Okay, you're going to do the validation. You're going to have things considering the regulation or the homologation what you have. Specification is very much important, and with that specification, with that standard, You're going to ensure that you're going to maintain the regulation, and you're also going to integrate, and you're also going to do all the system integration by also doing the benchmark and also respect to the change management. Benchmark again, it can be done with the global players, like how the other had done. So similar to that, you can have the benchmark for the three-wheeler, which I'm doing the consultancy work for a company, a startup company in Pune. So they have done a similar benchmark with the Ola Electric and also the Mahindra Electric, and again, um, it is like some other companies also they have done a benchmark, considering that they have done a design development testing. Now they are almost going to launch the vehicle, but launching will happen after the regulation approval from RI. Now they are in last stage. Okay, maybe it will take another 3 months for them to come for a SOP. Okay. So with respect to the test, with respect to the hybrid electric vehicle, it can be hybrid because both electric and engine, and when it can be a pure electric vehicle also. So when you're going for the test, what happens is it needs to do the steady state test where considering the durability and wear is very much important, and the performance and efficiency tests are being carried out. And the NVH test is there, and you also test the vehicle in altitude and climatic condition simulation. This is applicable for all the vehicles, like it can be the normal conventional thing without electric also. All these tests are very much quite common. Um, and even the thermal test and lubrication test also quite common for the engine, IC engine, and also for electric vehicle. And this test you do it in a steady state condition. But when you're going for a dynamic condition, what you do is you do the test in the functional test you do. You also do the shifting test. Okay? So you go do the test for a two-wheeler, the shifting test may not be applicable for, but for a four-wheeler, you need to have the synchronization test and for a shiftability test. And again, you also do the calibration, you need to calibrate under the different vehicle conditions and how it is going to perform. That also you will be testing. And you have the durability test. So as I said, you have the city test, you have the highway test, um, and you also do the NVH test and considering the different altitude and climatic simulation as well. Uh, now as the topic is with respect to the electric vehicle, so we need to concentrate on the hybrid the electric vehicle alone, for which you do the test in steady state and also the dynamic. So where you do the durability and wear test, you do the performance test, efficiency test, NVH test, altitude test, climatic condition test, thermal test, lubrication test, calibration test, synchronization test, functional testing test. So, and again, you also test with respect to the energy management system and also the battery management system as well. Okay. So I will take another 1 hour. Sorry for the delay. I do not want to directly start with the test. I want to do an overview. Kindly bear with the time. Uh, the verification and validation of the electric vehicle. So you see here, we need to have the validation, or we need to have why we need to have the testing. Okay, this testing will help us to ensure the performance of the vehicle, endurance, durability of the vehicle, reliability of the vehicle, safety of the vehicle, and also the life. We can determine the life of the vehicle basically. And again, the input what we are going to get is from the customer use cases. I will give you a real example. I have tested in a drive of a three-wheeler in a Pune condition. I will show you based on the customer use. That as an input, you can also test it. And you have the charging infrastructure as an input. You have the operating terrains. You have the environmental conditions. You have also changeover times. Considering all this an input, you need to have the verification and validation for your electric vehicle. So here you have the traction system where you test with respect to the speed, torque, efficiency, life cycle estimation of energy consumption, thermal characterization, NVH, and you have the battery in which you will have The other characteristics like involves the thermal management system. You also need to determine the life cycle of the battery. And with respect to power electronics is going to be the heart of electric vehicle, basically the battery management system or the motor control system. Power electronics is going to be very much important, and where you need to do the electromagnetic compatibility test and again electromagnetic interface test, and you need to do the thermal test, and you also need to do the specific energy consumption test. So when I say test, it also involves standards. Okay, first we will see the test, then we will see the standards, or we can see the evaluation how it is being done for the vehicle. So when I say it's ecosystem for electric vehicle, it involves a chain, a value chain. Okay, um, so we will see how this ecosystem it was before and how the ecosystem now. We will see the new ecosystem also, uh, and we'll see the development value chain. Basically, it involves R&D in which they do a lot of research with respect to the batteries. Okay, because nowadays in respect to the battery system, say of all the consultancy I work in two-wheeler, three-wheeler, four-wheeler segments. So I find that they are doing most of the research mostly with respect to the battery, okay, rather than the electric motor. Because what they are doing is they are going to have either permanent magnet or induction motor. So BLDC. So it is like they do not have any confusion with respect to the usage of the battery, with respect to the usage of the motor, but they are doing a lot of research with respect to the battery because the range, this gives the range again. Uh, and that's why they do a lot of research into the battery and the battery management system. And again, the raw material for this is lithium, carbon, silicon, carbide, magnesium, nickel. And again, what again the component involved is the battery cell, motor, and again the power electronic device. And subsystem what they have for batteries, battery module, motor, power electronics. But they do not have too much into the motors and system. But the battery module is going to be the most the research is happening in most of the uh, places in India and across globe. And system is going to be the battery pack traction system and again power electronic system. And with respect to the OEM point of view, the integration is the chain and the thermal system, management system, electrical losses you need to reduce, mechanical losses you need to reduce. You need to increase the stability, durability of these things. Safety again very much important because again you also have the standard for the safety, and again finally you are also going to recycle this. So these are the development value chain that you have for the electric vehicle ecosystem. And when I say the value chain of a complete electric vehicle industry, a new ecosystem has been developed. That is from the starting raw material to the finished good to the market. So when respect to the development, they are planning for in-house, completely it will be in-house. Basically, the make in India, what you call make in India, made in India. This type of things is helping actually. And the technology transfer, MOUs, partnerships, this will help actually. So with the help of Make in India concept, what happens is Indian companies, they also help, they also taking the MOU with some of the foreign companies for the development of technologies. So I even when I was developing when I'm developing the three-wheeler vehicle e-auto and e-rickshaw for a company in Pune, they also had a MOU with a foreign Israel-based company for one of the technology. Uh, see again, so this type of things will help during the development stage, and that will help not only in the development stage, it will also help the particular company to to have the manufacturing in-house with better technologies what had been followed in other countries as well. And again, even some of the companies are working as a joint venture, uh, maybe 50% with foreign companies and 50% with Indian companies. And apart from the development, the next important ecosystem is the sourcing. You need to get the motors, batteries, and the battery management system, motor control systems. All these systems, you need to have better sourcing. And again, And again, you need to have the CKD here is when I say it's a partnership, it will be 50% from other companies and 50% from Indian companies. CKD means you are going to get the parts from other countries, and SKD here is the localization. Localization you can do under the concept of Make in India. So you can develop the new ecosystem with the help of developing a complete value chain in the electric vehicle market. And you can do the assembly. It can be either semi-automated or fully automated, or even the subcontract manufacturing also you can do. So I when I was doing the work for a three-wheeler company, it was not started yet, but now they are when I was doing the prototype, initially they do the prototype. So it is completely manual kind of thing. Sometimes semi-automated. It's not completely automated. So you go with automation only when you go for startup production or where the volume is going to be higher. So next important thing is the distribution. The distribution is going to be how you're going to distribute your vehicle from your plant to the dealers. It is going to be quite challenging. And distribution means with respect to areas. So you have different states in India, how you are going to distribute. And again, how you are going to do the retailing and solutions for your vehicle. And again, how you are going to make it as an aftermarket. Okay, all these are going to be a new ecosystem which you need to create. So there is a good ecosystem has been created for development, sourcing, and still distribution, retailing, and aftermarket is in progress, because distribution in the sense uh, it is not that all the states in India is encouraging the electric vehicle, but uh, they may encourage inside their heart, but they have to come out with the real implementation. Okay, it is not that just by thinking I want to purchase the electric vehicle, the way electric vehicle will be sold. It is that they need to come up and they have to pay the money and they have to get the electric vehicle. Then only it will be a complete ecosystem. Okay, it is not that I want to purchase the electric vehicle, but you should purchase. Okay, it is you need to create the ecosystem in such a way that you should make that each and every people should have the electric vehicle. And having said that, the electric vehicle is very much important. It doesn't mean that uh, it is an end for a conventional thing. But see, as per the research, 2023, all the two-wheeler in India will be with electric. Sorry, all the three-wheeler. First, the government had put on norms for a three-wheeler. So all the three-wheeler in India will be with electric in the year 2023, and all the two-wheeler in India will be electric for a two-wheeler up in the year 2030, and beyond 2030, the focus will be for a four-wheeler. But again, it is not mandatory that all the four-wheeler will be electric in future. But again, the diesel vehicle also will be there, gasoline vehicle will also be there, and even the electric vehicle will also be there. But even the quantity or the volume should be going to be higher for all the three segments, with respect to the passenger car or with respect to the bus uh, or the heavy duty vehicle, because the range is very much important even for a four wheeler. Unlike two wheeler and three wheeler is okay, but the four wheeler range is very much important, considering that the research says that the gasoline vehicle will be there, diesel vehicle will be there, even the volume will be higher than what is there now, and even the electric vehicle will be there. But again, the volume will also be quite good. Okay, there will be increment in all the things. It is not that because of this electric vehicle there will be an end for for a diesel or gasoline. Even though electric vehicle is going to be a green, it's going to be a environmental free. And even there is research or a debate going on that to produce electricity which is coming from a thermal power plant, the pollution is going to be higher than what you're going to get from the mobile. Still a lot of debate is going on, but what you can do is that you can look for alternative source of getting the electricity from the nuclear power plant, apart from the coal, because burning the coal is also creating environmental problems. There are some other debates is going on other side, uh, but what I have shown in the well to wheel efficiency, okay, the efficiency is going to be good during the initial stage, but when it comes to the wheel, efficiency is going to be lesser. But again, the problem of emitting the pollution during the manufacturing of electricity through the coal. But instead of coal nowadays, even the research says that the bamboo, if you use bamboo, and you can also extract electricity out of bamboo, which are environmental free, which are good for non-pollution method, and even nuclear is also a good method. So all this you can try to ensure we are going to have the electricity with less pollution. Okay. So when I go for the CMVR stands for Centralized Motor Vehicle Regulation Act. In India, you have the different testing agencies like CAT, which stands for International Center for Automotive Technology. You have Automotive Research Association of India, right? You also have the VRD, which stands for Vehicle Research Development Establishment. You have the again RI, and again we have different association in respect to the industry like SIAM, which stands for Society of Indian Automobile Manufacturer, ACMA Automotive. Here ACMA is the component, like battery is a component, motor is a component, okay? The tire is a component, brake is a component. So, and when it says a complete manufacturer, it's a complete OEM or complete vehicle. And we also have the Tractor Manufacturing Association. We have the State Transport Department. So all these are the industry associations which are associated with the testing agencies, and even you also have the government norms like BAS, Bureau of Indian Standards. You also have the Ministry of Heavy Industries and Public Industry and Enterprises along with the Government of India. So all these are coming under the Department of Ministry of Road Transport and Highway, and you need to follow the rules, regulations, standards, and all the standards needs to be followed to test the vehicle, which are being done at ICAT, RI, VRDE, and also in all the different testing agencies. Even the test needs to be done in-house with respect to the companies. They will do their test in-house, and all this CMVR are been developed. The standards keep on changing. Okay, every year they keep on changing the standards. They also have the standing committee. The technical experts will be there in that committee, and they evaluate the standards. They test different conditions. So you have different tests respect to RI test procedure. You have the vehicle weighment test. You have the coast down test. You have the visual indication test. For a gradability test, you do the electric range test. You do the brake test. You do the noise test, electromagnetic compatibility test, function test, traction test, battery test. So all these tests are being carried out. So I have prepared a document for a different test for electric vehicle. Uh, so this is what the document I have prepared. This document involves the different type of test that normally the company be using. Hope my screen is visible. Can anyone confirm my screen is visible or not? Hello?
Yes, it's visible.
Yeah. Okay. So these are different type of tests that I have prepared. The standards and the requirement. So first you do the range and energy consumption test for your vehicle, and you do the motor power test, and under the condition of the 30 minutes, you find out what is the maximum power and minimum power you are going to get for the vehicle. And you do the electromagnetic compatibility test for your electric vehicle. You do the coast down test. Basically, you accelerate your vehicle to a high speed and again onto the flat and also to the straight road, and also to the different conditions. You can also take the vehicle with respect to the neutral down to the low speed as well. And we also do the test called the crash and impact test for the vehicle. We do the sled testing where because the airbag seatbelt will be there for the four-wheeler. So under that condition, you also do the sled testing, where you also ensure the safety of the passengers, the passive and the active safety, both you test basically. and you do the testing with respect to the thermal durability, thermal mapping, and behavior. Because the, the battery, as I said, you need to have the battery management system. And again, this also needs to be considered with respect to the, the temperature point of view. And this is it is one of the crucial validation process with respect to the electric vehicle, because it has a lot of impact onto the battery management basically. You have the safety test. It includes the the test with respect to the shock resistance. We have start-stop technology, and for which you need to do the start-stop test, and you will measure what is the range you are going to get and what is the impact that you are going to get out of the start-stop technology. And you have the fatigue durability test that we do normally in a vehicle. We also do the vehicle level braking test, constant test we do. We also do the environmental test with respect to the water flood test and rain shower test, where the vehicle will be kept into the place where you will pour the water into the vehicle, and you will see ensure that in the case of four-wheeler, the waterproofing test has been done, and in the case of two-wheeler also, you will pour the water and you will see is there any leakage you are going to get. You will apply some pressure also, and you see is there any leakage is going to happen. And you do a turning circle diameter test, where you 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 turn the car or a two-wheeler in a circle with the steering wheel turn to a maximum position in right or left direction. Considering that, you do the turning circle diameter test as well. And and again, you do the vehicle performance test according to the parameters. You have different parameters, okay, acceleration, deceleration, different conditions. Under that, you do the test. And you have different driving cycle for a two-wheeler, three-wheeler. Indian driving cycle we follow in India, and new European driving cycle we follow in Europe, and you also have um, the federal test procedure which is being followed in USA. These are all the different test cycle you have, where you have different distance, different duration, different average speed. Apart from that, you do the image test, gradient test, the state of charge test. You will ensure the performance of your charging system, constant speed test, energy efficiency test, on-road durability test, PT test, and again you do the suspension regenerative braking test, functional test, gradability test, and you do the speedometer calibration test also, even the electric shock test. So this is basically to ensure the safety of your vehicle, and you do the HVAC test. So remaining things we will see in a presentation point of view. Okay. Again, with respect to the test, you have the motor controller. So I said you will be testing the thing with respect to the complete vehicle and also the individual system like the controller. You will also test whether the controller is operating properly or not. Okay, all these have been done individually with respect to the individual uh, subsystem individually. And you also have the battery management system on battery, where you test with respect to the state of charge, state of discharge, and again this, the power, safety, all this you'll be testing individually. And with respect to the battery management system, you have important five categories, which will be determined or which will be evaluated or it will be tested with respect to the auxiliary and application later thing, with respect to the interface point of view, with respect to the balancing, with respect to performance management, also with respect to the protection. So with respect to the auxiliary related aspect, the pre-charging, contact control, cooling control are being tested. And with respect to the interface, the communication, because you're going to get this battery management system is mostly for the communication point of view and data logging point of view, and even it will display the status, what is the battery charging level. So for which you have the standards, you will also do the testing for the interface communication. And for balancing, you have the state of charge, state of health estimation. Here it indicates the charging percentage level of the battery. And you have the performance management system, where you do the temperature, current, voltage is equal to I into R, V is equal to IR. When voltage is higher, the current is also going to be higher. For which you do the performance management test, saying different voltage, different current, and you're also going to see the performance, how much will be the performance, and you're also going to do the safety test, whether you are going to have the protection against short circuit, overload, overcharge, or do deep discharge or overheating. So considering this, you are also going to have the protection. Okay. And then you have the charging system, like you have conductive, inductive, battery swap. So all this will undergo the standardization. Okay, you need to have the standards. Okay, we will see that standards in depth. So we have seen the inductive charging. It can be static or it can be dynamic. Static means you are going to charge when the vehicle is in static condition. Dynamic means it will go with light speed. It's not that it's going to go very fastly, maybe 10 kilometer per hour or to 15, 20 kilometer per hour. But under that condition, it will also get charged. Not even 20 kilometer, maybe very less speed, maybe 10 kilometer per hour. It will go very slowly. And you also have the system of battery swapping. Even you have the standards for these things. When you're swapping the two-wheeler battery or a four-wheeler battery, you have the standards that you need to follow. But the problem here is when you're going for a swapping the battery, you should ensure that you have the standardized battery interface. If you don't have the standardized battery with respect to the dimensions, then you cannot use the battery of swapping the battery. Then you need to go for a fast charging or a then you need to go for a either the plug in mode or the static mode or inductive mode you need to try. So when you're going for integration aspects of the change, so you have the effect with respect to the center of gravity of the vehicle, where your CG gets shifted the low side. You also have the suspension affected, one brakes gets affected, tire gets affected, safety gets affected, NVH is not going to get affected, but these are the parameters that you need to consider when you're going for a integration aspect of electric vehicle. Then the regulation basically the standards. So this is the ether vehicle where uh, center of gravity going to be get shifted and it is going to be lesser when compared to that of the conventional one. And according to this CG, you need to the weight gets distributed and it gets altered, and again it calls for design change with respect to the suspension, brakes, tires, etc. This is the initial level difficulty that I had faced, but now they come up with a very good design. The next one is the suspension. Even you need to do the test for the suspension, which to ensure that it is having a smooth ride, accurate steering, responsive handling, and also supports the weight of the vehicle. You have the individual test for suspension as well. Even you have the test for the brakes. It can be a disc brake or a drum brake. Still weight, load on the wheel. Just a minute, whether my voice is audible. Can anyone confirm my voice is audible?
Yes, now it's audible.
My screen is also visible, right?
Yes, it's visible.
So when you're going for the, the the test, so what I may observed is that the tire is going to get wear off like this. So then what happens is they are going with the modified tires where they are going to have uh, they are providing the channels shoulders to avoid voids to have the voids so that the tire wear is going to get lesser. So all these modifications are going to happen only when you test the vehicle. Okay, if you're not testing the vehicle, you cannot understand what is the problem really is. It is like you need to have the test, then according to the test, you will understand the failure, and accordingly the corrective action can be taken. You also have the safety issues that also needs to be tested using the safety standards. Then, with respect to the noise level, when compared to engine, the motor noise is lesser. Even though the motor noise is going to be lesser, but still you need to test what is the noise level of your vehicle. It can be the two-wheeler or a four-wheeler. So you need to see what is the noise level, and according to that, also need to test the vibration. Okay, noise is going to be lesser, but even the vibration you need to see because the overall weight, the battery weight is going to be higher. And so you need to see the weight distribution accordingly and how much is the vibration you're going to get. You need to ensure that the vibration test, you need to ensure that the natural frequency of the vehicle or the system should be higher than the expected frequency what had been determined. Uh, if your natural frequency is higher, then you will not get the resonance or the vibrate or the failure. So if it is nearing to that, and if you get resonance, then again there is a possibility that it may fail. So next we go with the evaluation standards for electric vehicle. So basically the regulations kind of thing. So with respect to the drive cycle, you have almost 250 drive cycles are available across the globe. These are the few drive cycles. You have European driving cycle, US driving cycle, Japanese driving cycle. You have the motorcycle drive cycle, which has been followed across globe. You have some of the passenger car drive cycle, modern driving cycle. Okay, and you have some Switzerland. Even in Swiss, they use the Swiss test cycle, which is named as EMPA driving cycle. So these are some of the few drive cycles that is being followed across globe with respect to different conditions. So this is the driving cycle. In India, we follow Indian driving cycle. In Europe, they follow the European driving cycle. This is the speed maximum they go with 120 km per hour. In India, they go with 90 km per hour, and in US, they go with 140 km per hour. So under the low speed, medium speed, and high speed, they test the vehicle. And new European driving cycle is this. Even we have the world harmonized transient light duty vehicle. So for a two wheeler and three wheeler, we go with this test. And with respect to the European driving cycle, you have the test having a different time versus speed, and you test with up to 150 km per hour for a car category. Okay, and this is the test cycle for a hybrid and electric vehicle, which means hybrid indicates it can be either parallel hybrid or a series hybrid. And electric vehicle, it's a pure electric vehicle. It's not a hybrid. So you see here, this is the driving range, having it a low speed, medium speed, high speed, and extra high speed, where it goes up to 130 kilometer per hour. So with respect to the time, see whatever it's highlighted in uh, in the blue color indicates the electric vehicle mode. You see the electric vehicle mode, it's a blue color, and whatever is highlighted in red is not been shown here, but this is the normal test cycle that normally you follow. Okay, this electric vehicle is been applied from low speed, medium speed, high speed, and extra speed. It is applicable for all the ranges. Whereas when you consider the parallel hybrid, it can go up to here, but it's not applicable throughout. Okay, but it's almost both electric vehicle and parallel hybrid or the series hybrid. It is applicable the range from the low speed, high speed, medium speed, and extra high speed also. So this is the driving cycle which is carried out in Pune uh, for a system which involves the testing of a three-wheeler, where this is the starting time, this is the end time, almost close to 10 minutes drive, having in the different speed range. Is done in a place called Savakar Nagar to Sarang Highway in Pune. And again, this is the different timings for almost again 8 minutes to 9 minutes. With again the test has been done with the elevation also, with the different elevations, and again with different gradient. The test has been carried out, and this is the place where the Savakar Nagar to FC Road, its own place, where the test is done in different timing. Again, it is almost 17 minutes. Again, the test is done with different elevation, different gradient. Okay, so all these tests are being done to ensure that there is no problem with respect to the system, basically. Just give me a second time. Just give me a second time. Sorry, actually the problem is 5 to 8. I have another meeting. Um, I extended the meeting. Sorry for the things, but uh, okay. So today I was slightly packed. The 3 to 8 continuous meeting and 3 to 5. Okay, there was a delay with respect to the lot of introduction I have given. Okay, so we follow different test cycle called NEDC, called New European Driving Cycle, and WLTP cycle test. So these tests are been done across globe. The world test, what you do is NEDC, and now what we are doing is worldwide harmonized light vehicle test procedure. This is come is already there across the globe. We follow this test to ensure that we are following all the guidelines, and we have different drive cycles, and we follow the test with respect to the time, with respect to different speed, different acceleration, different test, start stop application, different dynamics. Okay, the dynamics means with respect to the movement of the vehicle, and we follow different. Even in Japan we follow Japanese test cycle again. So these are the different test procedures that we have in respect to the standards, basically the regulation kind of thing. So you have CMVR, which stands for Central Motorized Vehicle Regulation Act. You have the different standards for two-wheeler, three-wheeler, e-rickshaw, four-wheeler, and also for buses. And this is related to it can be either for electric vehicle or hybrid electric vehicle or even retrofitment. You can remove the engine and you can convert that into electric vehicle also. And these are the standards we will see one by one. So you have the standards named AAS 038, which is for the requirements for construction and functional safety. AAS 039 for measurement of electrical energy consumption. AAS 040 for methods of measuring the range in kilometer. 004 for EMC. 041 for the powertrain vehicle measurement for the net power and the maximum 30 minutes power. I have shown this during the PDF document. So you have the 48 standard, which is for battery operated vehicle safety requirements, and you have 49 for CMVR approval, and you have 138 for charging stations. You have 102 for CMVR type approval, and you have AS 123 for CMVR type approval of hybrid electric system intended for retrofitment on vehicle. Uh, you also have the standards which is for your reference. So I will go with the different names like the electric energy consumption test, where we test using the driving cycle on the chassis dynamometer. This is a chassis dynamometer, where we will also measure what is the energy required per kilometer. And the important next is the measurement of range. We also measure the range of the vehicle in a single charge. What will be the range of the vehicle? It is not applicable only to two-wheeler, but it also for three-wheeler, four-wheeler as well. And next one is the AAS 041, where we do the maximum power test, where we test for 30 minutes and we measure the speed versus power. The next important thing is 49 AAS 049, where we test the electric vehicle with respect to the brake, gradability, speedometer, NVH, EMC. So all this will be testing with the help of the standard name AS049. So you also have the test considering the vibration. Basically, you test the random vibration test considering the frequency range in 10 to 20,000 to 2000 hertz and 5 to 200, depending upon the configuration of the batteries and the packing of the batteries. So you have different state of charge. Considering the different state of charge, you also test the vibration test for the vehicle. These are the different battery standards alone. When I say the standards, is not you have different standards. Okay, as per Society of Automobile Engineer International, so they follow different standards. Basically, for they have standards individually for motor, batteries, the different tests for brakes, suspension. You have individual standards, but you see, you have a lot of standards only for the batteries alone. These are the critical SAE standards, which will ensure the rating of the batteries. Basically, the even for labeling the batteries also you have the guideline, and even you also have the testing respect to the vibration because you need to test. Okay, for that you have the guidelines, and the abusive test also you have, for which you need to follow the guidelines, and you have the test with respect to the electromagnetic compatibility and even the strength point of view also. So you almost have many close to uh, 10 plus standards are there only for a batteries alone, which is being followed worldwide across globe. These are some of the electric vehicle standards that you normally go for when you're going for a charging. Okay, uh, so for a two-wheeler, three-wheeler, four-wheeler bus, so you have different agencies which will be certifying this the vehicle considering these standards. So even the standards is being followed across the globe is also going to be taken into account. For example, SAE J2293 is the one which will ensure the energy transfer system for a electric vehicle. You will have the detailed standard with respect to this system, this category. And you also have the IEEE standards, where it will also ensure that interconnecting the resource with the electric power system are being done in a much more effective manner. And you have the standards for the battery packaging and also for plugs, couplers, even for a electric vehicle charging standards you have. I told you you have different type of charging. It can be static, inductive plug type of thing, or it can be even AC charging or DC charging. And even you have the standard for the individual thing. Uh, and you have the power class connections, communication. For with respect to the each and every mode, you have the different standards and different criteria. Okay, all this needs to be maintained when you're going for the evaluation. With respect to the SAE international standards, you have the transparency is there, you have the consensus, you have the effectiveness. You're also addressing the concern of the developing countries like India, and you always have the coherence and openness. And they also try to eliminate the barrier, and at the same time, they are not reducing the standard efficiency. They are also trying to ensure that they are going to develop the standards considering the efficiency of the electric vehicle also. So they have the new era of mobility where they give the standards with respect to vehicle to grid, vehicle to infrastructure, vehicle to devices. Even the devices also having individual standards. with respect to the smart grid, connected vehicle, and also the electrified automobile. They again here the electrification is been implemented based on the consumer needs, what the consumer really wants, what the technology has been available, and based on regulation, based on the infrastructure as well. Uh, okay, just running out of this time, what I will do, these are the vehicle battery standards that have been put in use, considering the start-stop, concept application, battery packaging, hybrid application, labeling. Okay, all this you see almost different committees they have been forming. Almost 18 committees they are forming. Each and every individual committee will determine. They will prepare the list with respect to the standard point of view. They prepare the document. They release the document and they verify the document and then they implement it. They have different. They started in the year 2009, and you see different companies. Almost 140 companies are involved for the preparation. Almost 420 people from different companies. They normally nominate the experts in the particular department or department field, and they form the again again the committee will get revamped also. These are different linking standards that you have for electric vehicle and different hybrid electric vehicle. SAE J29 for the battery safety standards. You have the crash integrity testing standards. You have the standard for the battery testing alone, charging alone, safety alone, and you also have the ISO 6469 electric vehicle safety standards. And again, how you need to plug or charging, even the plugging also you have the standards. You have the vibration testing standards, and the conductive charge coupler. So when you are doing the conductive the charging system, when you are plugging it to the battery, how to the grid system, you also have the standards. So these are the relevant standard only you have only for a charging interface alone. You can see many things other with respect to the SAE for connector, communication, charging topology, interoperability, safety. Okay, so you have different thing for this alone. So these are different communication standards. You have SAE J2931, 1, 2, 3, up to 7. You have different 7 subdivision of this standard, which will have the scope considering the communication, signaling, and also the telematics, digital communication, and also the security of the plug-in electric vehicle charging system, basically. And you also have other supporting SAE electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle standards, considering the SAE J1711 or you have different thing where it will also determine the power rating of the vehicle, and also it will determine the charging of the system. So you have the Environmental Protection Agency rating, EPA rating, like what we have the mileage for a IC engine, you have the range for a electric vehicle, basically the miles per gallons gasoline engine rating. So this miles per gasoline equivalent range is very much important, which will determine the standard for a electric vehicle. So even MPG is also very much important. Similarly, what we have the regulation for a gasoline or diesel vehicle, similar regulation is applicable for a electric vehicle also. Uh, so here you need to have the MPGE or the miles per gallon gasoline equivalency. So here gasoline is like per gallon basically. So here you see here under city condition, under highway condition, you need to have MPG value of 24 kilowatts per hour for 100 minutes. So all these ratings is very much important. How the mileage is important for IC engines. So these are the different EPA rating that you have, Environmental Protection Agency rating for different electric vehicle, for different vehicle category, and also different size of the battery, and according to the size, you also have the different EPA range and different MPG rate, and also the EPA range uh, kilowatt hour. So this divided by this, okay, that will give you the EPA range per kilowatt hour. What is the maximum charge in terms of kilowatt hours also given here. With respect to the battery point of view, we normally test the performance test, which involves state of charge, state of health, energy efficiency. We test all these things. And with respect to the battery management system, we test the things considering what will be the energy level, charging level, the impedance of the cell, and what is the maximum discharge current, what is the maximum discharge limit, current limit, charging limit, maximum charge current. So all this we'll be testing, and even we do the durability test to ensure that what is the maximum number of cycles it can withstand. And we do the lot of tests and standards with respect to the communication point of view, because this communication is very much important, whether the communication is going to be perfect both internally and also externally. And according to this, you can also ensure that you have separate communication system, what I have been told, for a wireless and also for a closed area network. This is the system of a communication using the battery management system, where you have closed area network and also you have the 485 controller. And using this, this is the example of a two-wheeler battery management system, where you are going to get the complete integration being done with the help of battery management system along with the controller and also along with the motor along with the battery. This is the different parts of a components and connection for a two-wheeler. This is and again you are going to test the motor alone also individually with respect to the rated power, rated speed, rated torque, rated current, efficiency, ratio, rated speed. Even you should have a less weight also. So all these are things to be taken, parameters are needs to be taken when you are considering the standards and also testing. So when you are considering the controller, uh, all these parameters are very much essential, and for all these parameters you have the individual standards as well. So it is not that this testing and standards can be explained in an hour, but it's a very deep topic. Just given you an overview, and these are some of the three-wheeler electric vehicles we have in India. Uh, Bajaj REV is a rechargeable electric energy efficient vehicle. So you have Mahindra Trio, you have Kinetic Safar, you have Piaggio. So this all these are been taken as a benchmark for the one I told, which I'm doing for a Pune-based company. And you have the different maximum speed. How much is the range you see? The charging timing is also can be. You see, only when you're going for a swappable battery, you have only 6 minutes. In 6 minutes, you can charge it. That is one advantage that Piaggio Ape City had done. So this is last but one slide for me. So you being a faculty and the research scholar or a researcher, so what are domains and the areas that you have in respect to the electric vehicles? You have a lot of scope where you can do with respect to the research or a career opportunities. Maybe sometimes you want to do PhD, you can do it in power electronics, connected vehicle. You can do it in electrochemistry, thermal management, power electronics, material science and metallurgy, and again algorithms and vehicle engineering. All these are the research scope that you have for a electric vehicle. Definitely, I can help you for your research activities or or some of your projects. Maybe I can guide you, basically even for your PhD also. You please feel free to contact me. My mail ID is p.arjunraj@gmail.com, and my mobile number is 8778983428. Thanks for an opportunity, and you can ask your questions now.
Hi Arjun. Very good session, a very good overview. Just one question I have. Do you have any experience with the using the phase change coolant in the four-wheeler
Phase change?
coolant? So instead of ethylene glycol, some four-wheelers.
Yes. Yeah, there are a lot of coolant are being used, but currently, basically, I was doing the work for a two-wheeler, three-wheeler, but for a four-wheeler, it is quite complicated. And again, you need to have the battery cooling system, which involves a lot of liquid-based thing. Um, I don't have the experience onto that, but what happens is in the case of two-wheeler and the three-wheeler, where you have a air cooling system, when the vehicle is moving with the help of the air cooling itself, it acts as a coolant for the battery management system. But unlike the case of the four-wheeler, even the temperature is going to be higher.
Yeah,
I,
I
I
got
have
it.
not, yeah, I have not used that, but there are a lot of liquids are there, or a lot of coolants are there, like what you have in the case of the ethylene glycol, what you have for a normal conventional vehicle.
Yep. Yeah, agreed. Agreed. The other question is like battery's biggest challenge is thermal runaways, right? So we do at the battery level, but at the vehicle, what type of test we will do to check like the possibility of thermal runaways?
Okay, so individually we apply the temperature when you're testing the battery. We give the high temperature and we evaluate the efficiency or the test of the battery. But with respect to the vehicle point of view, we keep the vehicle and we keep the battery into the vehicle. And what we do is we do the durability test and we do the different tests, like we do the medium level test, we do the high speed test, and different range test we do. And after that, we evaluate per charge, like after charging the battery 100% charge, what's the range it is going to give. And then and during the range, at particular time, it will reach to 50% state of charge. What is the time required for 50% state of charge and 80% state of charge? And then we also give an overview that what is the time required for the complete discharge, and what is the time required for charging the battery in the vehicle condition, considering the temperature of the surrounding as well.
Oh, okay, got it. Thank you. Would you be sharing this presentation by any chance?
Uh, okay, I will share some of the important things, and then yeah, whatever is not sensitive, I will be sharing.
Okay, thank you.
But I can send you the PDF document, which is very much which will give you all the information. I will send you that PDF that is quite interesting, that is quite informative also.
Yeah, that would be fine. Thank you. Yeah, I will drop you an email requesting the same thing. You can meet something. Okay.
Any more questions from participants?
Let's see any questions are being put in the chat box.
Yeah, definitely.
Okay, no questions are there.
Okay, so shall I conclude this session, sir? Hello, am I?
Yeah, thank you. Then you can email me. You can ask the participants to email me.
Yeah, definitely. I'll take this image, and whenever anybody talks about this, I'll definitely share. So thank you very much, Arjunraj sir, for your valuable time. And I think you almost have said many things related to testing of EV vehicles. And almost two, three people had asked their query, and you have responded well. So this shows quite emerging area, emerging field, which is way forward. Okay. So definitely your session was really good, and it was really contentive session, I would rather say. Thank you very much again on behalf of Automobile Engineering Department ADIT. I again offer my sincere gratitude for sparing your time for on the platform of HTTP called Automobile Engines, Emission and Green Fuel Technology. Sir, thank you very much. We will be grateful. We may have another session if we arrange some another HTTP on this or similar to this topic.
Yeah, sure. And because I did not directly enter into testing and standard because I need to give an overview. That's why it took more time. And maybe we can also focus more to the standards also in further STTP. And then we can I will come up with some new topics.
No issue, sir. Welcome, welcome.